So in 6.2, we're going to take a look at adding and subtracting rational expressions. The rules for them are the same. However, we're going to break it up into two situations. One where you have rational expressions with the same denominator, and then one where they are different. When they're the same, it's definitely much more straightforward, just like with regular fraction rules. And in fact, that's very important to make sure you do understand basic fraction, addition, and subtraction rules. That will make these rules make a whole lot more sense. Because when we're looking at fractions with the same denominator, it is very simple. Once those match, you're allowed to combine the numerators. Now, we'll talk more about subtraction, being careful there. But combining the numerators and then just making sure we can't reduce it further, like we were seeing in the last section. So, for our first example, we see the 20x matches. They have the same denominator. So, we can put them together over a single fraction. Simple as that. 7 plus 3. Adding across the numerators would give me 10 over 20x. And in this case, this would be a place where we're allowed to reduce or simplify. All right, this is just a 10. This is 20 times x. This is a factor. So 10 and 20 reduced to 1 and 2. And that would be our final reduced answer there. Looking at number 2, we have matching denominators of 6x plus 5. So we can combine them into one fraction. 5x plus 4 plus x plus 1, just adding straight across. Now, combining those like terms, I get a 6x plus 5 over 6x plus 5. And I want to really point something out here specifically. I'm not going to say the 6x's cancel and the 5 cancel. What I'll say is, since neither of these things factor at all, that is a factor and that is a factor. Again, think of it like it's times 1, but that is how they cancel, leaving us with 1 over 1, so reducing down to a 1 there. All right, next one. We've got a common denominator there of 6 plus y, so we can put our numerators together. Now, there was a subtraction there, but it was just y squared minus 36 to create that numerator. Now, here we want to say, remind ourselves back from section 6.1, that if we want to see if something something reduces, it may involve factoring first. And in fact, we should always try to factor first. Y minus 6 is the difference of squares that factors down to y plus 6 times y minus 6. So we definitely want to do that. And like we saw in the last section, this y plus 6 up here and this 6 plus y down here, now again, that doesn't factor, but can be thought of as itself a factor times 1. And these two are exactly the same, right? There's no negative trick involved. Those are the same factor. Left with y minus 6 up top and 1 on bottom means we're actually just left with y minus 6. We don't even need to write that as a fraction because we don't need to write a denominator of a 1. All right, and over to example 4. One more with the same denominator. Now, that's the denominator. When you go to the numerator, it's 2y minus y plus 1. This is why I keep writing out all these numerators. It's very critical that we understand that that is actually what's happening here. We are subtracting all the numerator, the entire set of terms of y plus 1. So we would want to distribute that 2y minus 1. Then combine like terms. That would combine to a y. Now, as we do this, the denominator, we have not asked the question yet whether that factors. So let's do that too, because if we're going to reduce this, if it does reduce, we would need to see numerator and denominator factored. We just simplified the numerator, and that's not going to factor at all. But y squared plus y minus 2, notice that is it looks like an easy case, and one that does factor. Numbers that multiply to negative 2 and add to positive 1 would be a positive 2 and a negative 1. And thus we have, again up here, with y minus 1 not factoring, being itself a factor, canceling with that y minus 1 below. Now notice here it's important, the 1 that's left over is on top. The y plus 2 is in the denominator, so our final answer would be 1 over y plus 2. Very different from the previous example where the 1 was in the denominator, so all you did was write the numerator. Very important to point out the difference in those two examples there. But now, let's take a look at a couple slightly simpler examples where we do not have those matching denominators. So the process is mentioned up here, and it really just boils down to find the denominator, find that common denominator, and then rewrite the rational expressions so they have the common denominator, right? So again, just like fractions, only the twist of we're dealing with these expressions instead of just numbers. So for our first set of fractions here, we need to find the LCD. Now in this case, it's not too bad because it's just a number and some multiples of variables. So I can look at my numbers, 3 and 5, and say their LCD is 15. I can look at an a and an a cubed and think about how many a's would I need so that either one of these could go into it, right? That's the LCD. You're looking for what these go into. Well, we would need a cubed, right? We would have the a needed there, but we'd have all 3 a's needed there as well. And then here we've got b cubed and b squared. Well, that means we're going to need b cubed as well, because we need to find 3 b's in there. And if we've got 3 b's, then we definitely will find 2 b's. Notice the difference there. We did not say that the LCD of 3 and 2 was 6. Right? We did not make this b to the 6th. That's important. Because notice, with that LCD, now what I'm going to do is I have to take the time to rewrite both these fractions with that as the denominator. 15a cubed b cubed. That's what we need in both those denominators for them to match. So the question, just like with regular fractions, is what did I do to that denominator? What do you do to 3ab cubed to turn it into 15a cubed b cubed? Well, you multiply by a 5 to turn the 3 into a 15, and to get from a to a cubed would require a squared more. You're looking for the factors necessary to get you from this denominator to the LCD. And once you find that, you use that exact same multiplication on your numerator, so 7 times that 5a squared, giving me 35a squared. So it's the same with, just like with regular fractions. Whatever you do to the bottom, you do to the top. It's just about that question of what did you do to the bottom to get there. Same thing here. To get from this denominator to there, from 5a cubed b squared to 15a cubed b cubed, would take a 3. 5 times 3 is 15. I've got all the a's. I had b squared. I need b cubed. So I need 1 additional b. And that is then what I'll multiply the 2 by. 2 times 3b to get 6b. But now those have a common denominator, so we can combine them. 35a squared plus 6b across the top. And this does not factor at all, right? No GCFs and nothing else. So if this doesn't factor, we're not going to find any common factors to cancel there. So that is its reduced final form. Now the next one is one that can be tricky. Doesn't look like there's much going on. Certainly the denominators don't currently match, but the question of what is the LCD can be a tricky one, because people can be tempted to say, well, this has an x and this is x minus 1, so it must be x minus 1. But remember, we have to think about it as factors. And if this x minus 1 is there, it's itself a factor. We have to think of it as one thing. X is a different factor, right? And so we need each of those factors in our LCD. A factor of x and a factor of x minus 1. And you'll see why we have to do that here in a second, because as we go to that next question of rewriting both these fractions with that LCD, we have to be able to answer this question of, we had this in the denominator, now we have this, what do we multiply by, right? So we had x minus 1 as a factor, now we have x times x minus 1, so we multiplied by an x, right? That's the factor we just introduced there, so that's the factor we'll multiply up top by. 1 times x is just x. And then same thing here, to get from this denominator to our new denominator. X times what gives me x times x minus 1. Well, there's that missing factor, or that additional factor of x minus 1. So 1 times x minus 1, which would just be x minus 1 in this case. Now they match, so now we can combine them. However, again, be careful. With subtraction, x minus that, I have to write it as minus that whole expression. Be very careful. Do not be tempted to cancel these things right now. I know they look common. This is not a factor of the numerator. I just put it in parentheses to see the distribution. This is really just extra terms up here in the numerator. So do not cancel. We only cancel common factors, which happens after you combine stuff. Now combining that, x minus x is gone, and that leaves me with that. And I'm not going to factor this at all, which means this is not going to reduce at all, which means that is our final answer.